Okay, so I think we should be live now, and if there's any kinds of issues, hello, Luca. Let me just quickly, can you mute? So I think there should be everything set up on YouTube as well. So hello everyone on YouTube.
So I think
and
we should be live now,
okay,
and
myself
if there's any kinds of issues,
something.
hello, Luca.
Just a second.
Let me just quickly, can you mute?
Close this.
So
Okay, sorry, technical issues. I had an extra YouTube tab open, so you can probably hear some echo from myself. Regardless of that, thank you everyone for coming. We'll quickly start off with a small presentation on what GDG is and what our talk is going to be about today. So we'll be talking about exciting AI today. We have two really cool topics. First off, we'll have Joshua who'll talk to us about Vertex AI Vizier, which is a pretty cool Google tool that it seems like not a lot of people have heard about, but it's actually very useful. Next up, after a small Q&A session, we have Kshitiz, who will talk about generative deep learning and some of the tools that you can use today that will help you generate some things like art and stuff like that, and how you can actually use them in your daily lives. So let me quickly switch over to the presentation. In terms of the GDG program, I really want to kind of emphasize that we're a very nice community overall in the GDG. This is the GDG Osijek event, a chapter here in Osijek, Croatia. If you're not sure what GDG is in general, it's a Google Developers Group program that lets you connect with other people that are in the tech market, in the tech space. It helps you grow by learning some new things from presentations, from code labs, from workshops, and many different activities that you can find. And then you can kind of use those tools and use those new skills to grow your career, to maybe start a new business, or start a side project like we all do. You can find this link or you can use this link to look up the program. You can see if there's any GDG chapters in your country or in your region, if there's more than one chapter. And you can kind of follow everything that's going on, not just for our chapter, but also other. If you want to get in touch with us, you can kind of scan this QR code. And there's a few links here that we'll share after the presentation. We'll share it in the YouTube, so the actual video that's going to be published later. But yeah, that's about it about the GDG program and what we want to do here. So feel free to reach out to us. Feel free to present your ideas if you have any, and we'll try to organize some new cool events. So let me quickly switch back to the actual call. Joshua, can you share your presentation now? And we should be good to go.
Thank you, Philip. Vertex AI Vizier for black box optimization. I'm Joshua Fox. I'm a senior cloud architect at Do It International. I help technology companies with Google Cloud and AWS, and I am a Google developer expert, which means that I travel the world and give talks about Google Cloud topics. I'm not a Google employee, but I work closely with Google. And one of the areas that I specialize in is MLOps, machine learning operations. That means making sure that the data ingestion, data cleansing, machine learning training, deployment for inference, monitoring metrics, that these all happen smoothly. Many of my customers struggle with this problem. A long, costly process doesn't come out good enough. For example, machine learning training, and they want to try again. But they don't know with what parameters to retry it, and they don't want to just guess because it's expensive and slow. That's what we just said. So what do you do once you've done your machine learning training over and over? It's 3 in the morning. You're going to do it again. It's not good enough. You're wasting time and money on each cycle. The agenda today: what is black box optimization, and how you use that with iterative trials. That's what characterizes black box optimization. Black box optimization is usually spoken about in the context of machine learning, but in fact, it does far more than that, and it can be used in other systems as well, as I will describe. And what's really nice about this talk is that this has never been given in a public forum before. It's actually amazing. You cannot find this on YouTube. There have been talks about the research project that came first, and there's a little 10-minute talk, but Google Marketing has not been speaking about this. So that's great. You get to hear something in the first public open talk ever. And some of these things will be very new, including the fact that Vizier has come out in many variants. So it's a brand name, and Google keeps reusing it. That's fine, but it gets very confusing, and I will clear that up. And I will present some of the first ever machine learning code samples. I'll also present the lab, which means you can go afterwards and try it yourself. I'll explain how. And of course, Q&A. What is black box optimization? This is not specific to machine learning. It works for many different optimization problems. Black box optimization shines when you have no information about the gradients or other aspects of the function. So think about machine learning. The training tries to find the maximum function. It goes up the hill, down the hill, it tries to find the highest point in the hill. And it's doing this millions of times a second or whatever. But when you're doing multiple training runs, each training run takes an hour or whatever. So all you know is that the training run came out pretty good, not so good, you know nothing else. That's when you use black box. Also, when the evaluation is slow and expensive, such as machine learning training. Some example use cases. Not machine learning necessarily. A/B testing for websites. So you run your website, and the next day you run it again with different layout, different colors, different features, and you see which increases the user retention or the revenue the most. You might even run A/B at the same time. But this is expensive, because if your e-commerce site doesn't have the maximum amount of sales because you were testing, you've lost a lot of money, and it may take a day, 2 days just to figure things out. How do you know what parameters to choose in designing that A or that B or C, D version of the website? Supply chain optimization in manufacturing. Every morning in a factory, you choose what the inputs are, and you want the least expensive way to make the most possible outputs. What are the correct inputs to use? If you make a mistake, then your factory has lost tens of thousands of potentially of dollars, and you can only change it, let's say, every day. Another use case is X squared. Okay, so that is not expensive and slow, but Google gives us an example for your testing, because when you're working with Vizier, every single cycle we said is expensive. You're doing machine learning training. So if instead you're doing X squared, then you can just do the Vizier cycles many, many times. And the point made by X squared is that Vizier can be used for almost any problem. It's just more suitable for certain types of problems. And hyperparameter tuning for machine learning, which really is the classic use case. So for example, choosing the algorithm is itself something that you need to decide with machine learning. If you're trying to maximize the many different possible algorithms, that is a parameter. Also, regularization and learning rate, which is how fast the training is going to find the correct answer. We all want to work quickly, but if you go too quickly, it will miss the target. In a neural network, the number of hidden layers, the size of layers, these are all examples. This works with any machine learning, even not Google. You could be working in a container with your own algorithm. You could be calling Google APIs, or even calling APIs on the outside. Vizier does not even know that you're doing machine learning. All it knows, I'll show you in a minute, is how well each cycle is doing. So this is the usage pattern with iterative trials. In Vizier, you create a study, and you run multiple trials. Each time you tell Vizier, you stream back how good it was, the evaluation, the metric. For example, balanced accuracy in the case of machine learning. Another example might be revenue for an A/B test. And you also tell Vizier what parameters you use. And the Vizier will send back, as a result of the REST invocation, suggested parameters for the next trial or multiple trials. And then you do it again, many trials, over and over and over. You can take Vizier suggestions, or you can use your own parameters. Vizier is just suggesting. And even so, when you feed back the success, the metric, back to Vizier, and you tell it that, it will learn from that. I've been talking about this sequentially, but these trials could be parallel. The advantage of, let's say, doing 5 at a time is that it goes faster. But the advantage of doing them sequentially is that way, when you do the 5th, Vizier has already learned from the first 4. Of course, if you've done 5 together, Vizier can't learn from the first 4. At the end, you take the best parameter set of all those many, let's say, machine learning trainings, and you're ready to go. This is software as a service. Nothing to deploy, you just invoke it with REST, although just recently it came out as open source, which I'll talk about just a couple minutes, a little bit later. So this is an example of what it looks like. You're sending Vizier the input, which is the parameters. Let's say, in this cookie baking example, the research team actually did this. They baked cookies, and they had evaluators decide how good the cookies were. Let's say average 8.1. After all, you don't want to bake thousands of cookie recipes. That costs a lot of time and money. So the research team did this to determine the best recipe. And Vizier sent back, as a result of the rest, let's take this example, the next recipe to use, the name of the recipe, which is a choice from a number of options, the number of eggs, which is an integer, and flour, which is a floating point, just as an example. This is a simplified example, but it pretty much represents what you're sending in that rest. Vizier is an advisor. It just makes suggestions. It does not do machine learning at all. It doesn't even know you're doing machine learning. The word Vizier comes from Arabic wazir, which passed through Persian, Turkish, and into English. And this is an advisor to the king who does not actually make any decisions. It's a different way of approaching that. I will talk about that in a minute. Let's compare that to regular hyperparameter tuning. So with the, let's say, old-fashioned, if I could use that word, old-fashioned hyperparameter tuning, you give it a range of hyperparameters, fire and forget. So here the example is the hyperparameter range is the learning rate eta, which varies continuously from 0 to 1, and an integer, which could be 0, 1, 2, or 3. And you create this hyperparameter tuner object, and you say, fit, go. Come back in 5 hours, come back after many hours, run many, many machine learning trainings behind the scenes, and just tell me what's the best. So that sounds good. You just have this one simple method. I'll explain the difference, though, why black box has advantages. So black box, the word black box means Vizier does not know what you are doing inside each iteration. The machine learning training and A/B testing are visible to you. You're the expert, but not to Vizier. So the opposite, white box, which is not an official word, but that's regular hyperparameter tuning, where the tuner runs the machine learning training and it's hidden from you. To compare, hyperparameter tuner is fire and forget. In black box, you run what is inside the loops. You're totally in charge. You run the slow, costly process. In hyperparameter tuner, the tuner makes the parameter choice, but with Vizier, just making suggestions. Hyperparameter tuner, because it is a closed integrated system, is only for machine learning. But black box doesn't care. And with hyperparameter tuner, the scalability and robustness could be limited by the fact, if you think about it, you're calling fit. That function, what happens if it crashes after 4.5 hours? You just have to start again. So black box is more scalable and robust. We can understand that by looking at this architecture diagram from the research paper that originally was published in 2017. So you see here that it is reliable because there is a persistent database of these trials. When we do fit, look, it can be implemented in many different ways, but at least in principle, it doesn't have to be a database. Here, if something crashes, the information is in the database for a potential rerun or potential continuation. On the other hand, maybe if something is crashing all the time, we can just ignore that, and we know that fact because of the persistent database. It is scalable to millions of trials because you do the heavy lifting. As you see here, in the lower right, the heavy lifting, the evaluation workers are on your side. You're the expert in machine learning. You're the expert in A/B testing. You know how to configure it to save money. Look, you're doing machine learning training anyway. hopefully you're saving money, you're doing it the right way. If not, that's another problem. But no hyperparameter tuner will do that for you. And because of this, Vizier can scale up massively because it doesn't have to worry about that heavy-duty machine learning. Vizier has state-of-the-art algorithms for its suggestion service backed up by suggestion workers. So these suggestion workers are spawned off, they run in parallel behind the scenes, and they can run one of several different algorithms. One is, the simplest maybe, is a random search, just jumping around to different possible parameters. You might say, oh, what good is that? But think about what you're doing at 3 in the morning when your machine learning is not good enough. You say, oh, it didn't work with these parameters. Oh, I'll use some other ones. Well, how are you choosing those? So yeah, you can jump around randomly, and Vizier still keeps track of everything. Vizier can also do a grid search. That means that if you gave it the options 1, 2, 3, it will try each of those stepping. If you gave it the space from 0 to 1, it will maybe cut that into quarters and go a quarter, a half, 3/4, 1. That's a grid. However, Vizier can also do a Bayesian search. That is when it makes a model of this meta, let's say this hyperparameter tuning, and it tries to find the best space in the parameter, up in the parameter space. It's very easy to use with a small REST API, and it's flexible. You can plug in new algorithms for research, and you can see that most clearly in the open source project, which I'll mention briefly later. It is a hyperparameter tuner. After all, the Google AI platform hyperparameter tuner is implemented on the basis of an older version of Vizier, but it's more than that. It can suggest when to stop. So it suggested that you multiply the number of parameters by 10 and do that many trials. That's just a guess. So you have 2 parameters, run 20 trials. You could do that. But you can also ask Vizier, should I stop? It's just a suggestion, like everything else. And it does this, you check the trial early stopping state. Let's look at this graph from the research paper. If you're going on that dotted orange line, things are getting better and better rapidly. So yeah, keep going. You're going to get some benefit. On the other hand, if you're finding that the improvement is along the lines of those solid lines on top, then you might be wasting money with doing too much A/B testing, too much machine learning. And if it's a green dotted line, it's actually getting worse. Stop. You can have Vizier suggest what to stop. Here's another advanced feature. Multiple objective metrics. Let's say you're running a 2-sided marketplace and you want your buyers to be happy, but you also want the sellers to be happy. So Vizier can help you with maximizing both of them. You want users to spend a lot of time on the site, but you also want to increase revenue. How do you optimize both? Or you're optimizing across these 2 trigonometric functions, our sine theta, our cosine theta. That last example is obviously not a real one, but it helps because I generated these graphs on Wolfram Alpha. And you can see that no one point will give you the best results. Instead, Vizier gives you a Pareto frontier. That means a line along which you cannot make one metric better without making the other worse. So instead of giving you back a suggestion, it gives you back multiple suggestions along the frontier. That's very unusual. Usually when you're optimizing multiple metrics, you just take an average, you combine them somehow. So this is a Pareto frontier. The algorithmic configuration is provided with something called a study spec. Now, I want to say this is optional, and I'm not sure you want to use it. And the reason is that Vizier is already a hyper optimizer. Already you have machine learning, which is doing some sort of really expensive optimizing. And then Vizier says, let's do it many times. Well, hopefully as few times as possible. But still, it's getting expensive as you do more and more machine learning training sessions. If you say that a Vizier study isn't good enough and you want to do another Vizier study, you're multiplying the number of runs exponentially. Instead, you can trust Vizier to converge on a good answer. However, if you know what your problem looks like, then you can tell Vizier some things. You can give an early stopping rule. You can say, I want you to stop when the last few are not getting any better. Or you can say, I want to stop when the last few are no better than the mean than the average of all the previous ones. You can choose a search algorithm, as I mentioned earlier, and you can tell Vizier which way to choose the best metric. So you might think that if you do, let's say, 20 trials, and you want to choose the best, right? In this graph here, you see that one of these was the best. And actually, that's the default. It's a good way to work. However, what if it is a noisy process, as seen in this graph? Yes, it's getting better and better and better, but that best is probably just the result of random noise. And that's called the winner's curse. It means you win. You got the best one. But the curse is that that's just the result of randomness. So instead, you can say, take the last one, because the last one is the result of a slowly increasing and improving process, if you happen to know that this is noisy. The parameter scaling type. So the default is that you can tell it to work in a linear way. That means that if one of the parameters goes from 0 to 1, it might just step along as a quarter after 3/4. But what if your parameter ranges, as you see here, from 0.0001 to 100, from 100 to a billion? Well, obviously, you want it to step along, not in evenly spaced steps. So instead, you tell it that it's logarithmic, and it should say, let's go 10 to the minus 4th, 10 to the minus 3rd, minus 2nd, and so on. You can also say reverse logarithmic, where instead of squashing the big numbers, you squash the lower numbers. Depends how you know that your parameter is arranged. Parent category. That means that if you have multiple, in this example, if you have multiple models, you know that some of the parameters are relevant to only some of them. So for example, let's say we have 2 machine learning models, linear and wide and deep. It doesn't matter what these are. It really doesn't matter what these are because Vizier does not even know. But they're just 2 ways to machine learning algorithms. And linear is very simple. However, wide and deep is a deep neural network. And therefore, the CNN learning rate is only relevant in that case. So you tell Vizier, don't try to find me the best CNN learning rate if you're exploring linear. Only do it if you're exploring wide and deep. It's the parent category. It's called a category because it's one of several choices. It's not a number that ranges from a low to a high value. Resuming the earlier study. This is done with transfer learning. And that means, let's say, for example, that you did an A/B test and you try different variations and choose the best. A month later, the product managers come to you and they say, we want to change the website. Okay, let's do another A/B test. But you want to get the value out of the previous one. So you can tell Vizier to continue with the previous one and just add more learning to that one. This only exists in AI platform hyperparameter tuning, which is exposing Vizier. Resume previous job ID. By the way, this might give you a clue as to why you might ignore Vizier's suggestions and use other parameters. You're doing your A/B test, and then the product managers come to you and they say, no, we want it to be green. We want all the font to be 2 pixels wide, whatever they say. So of course, you're going to cooperate with the product managers and use the parameters they suggest, not the ones Vizier suggested, but you can feed those back to Vizier, it will still learn. Pricing. It is free if you use random search or grid search. However, if you use the default Bayesian algorithm, you only get 100 trials free and then $1 per trial. This is nothing because you're doing machine learning training, which is expensive. $10, $100 per training run. A/B testing is expensive. $1 is nothing because it reduces the number of trials. Now I'm going to briefly talk about the variations of Vizier, because this is the thing that I found the most difficult when I learned it, way more difficult than the technical material. So it's just a brand name that's used for different things. Originally the research paper, then it was an engine for the old AI platform, hyperparameter tuning, and AutoML, which is a way of, which is a service that will run multiple ML training cycles for you and find you the best one. However, recently they came out with 2 platforms for Vizier. One is Vertex AI Vizier, the other is AI Platform Vizier. I'll talk about that. That's probably the main point of confusion. And then, just a month ago, they came out with the open source. Now, the open source is interesting. I recommend looking at the source code. You're probably not going to use it because it's way easier to use a service. After all, if you use the open source, you have to pay for the hardware. Further, they did not release their core algorithm in the open source, what I call Bayesian. So practically speaking, you're always going to be using software as a service. Still, the open source makes things a lot clearer because as a software developer, you say, oh, it's just software, that's how it's designed. So it helps as a learning aid. Vertex AI Vizier is the one I suggest you focus on. It's generally available. However, it was also backported to the old AI platform, and that is a beta. The APIs are as follows. Vertex Service Client is a Python class with functions, of course. The other API is discovery-based. That means if you look at the source code, you won't see any functions. It works dynamically. You call it with functions, and internally it does some meta-programming trickery. It turns out it's actually not that difficult to use. Plus, you're not going to be using it. You're going to be using the more modern, future-looking Vertex Vizier API. And you may find as you go through different documentation that the same things are used without the Vizier branding. It's also used extensively inside Google for internal purposes. There are very few samples out there, and Google did not even release a machine learning example for Vertex Vizier API. They did for the AI platform. And now I'm going to very briefly go through a code sample. 2 notebooks I put together. If you do it yourself, just look for the marking hash 0, hash 1, like you see here. This was the first ever example, except for the lab, although there have been a few articles that have come out in the last year if you want to look for those. So let's look at that. This is the GAPIC Vertex API. It's called GAPIC. It's just another name based on the marshalling layer. If you see that, if you see GAPIC, that's all it means. So let's look at 0. Here in this notebook, we're setting up a totally normal machine learning task. And we're going to be doing a totally normal machine learning task. The separation between that and Vizier is important. Here we're talking about Vizier. These are the parameters that Vizier will explore. As you see, some are doubles and some are integers. Also, they can be categorical. So this is the space that Vizier will explore. We're going to be using balanced accuracy as our metric. That's what I call it. Vizier doesn't care. It's just a name for Vizier. And unspecified algorithm means Bayesian, the fancy one. So we create the Vizier service client. That is really the core of the API that you have to learn. And now we're going to be doing multiple trials. So here I just did a fixed number. In fact, it's just 2 to save you money. You can increase that to 20, or you can ask Vizier for advice. And we're going to do multiple loops of do trials. Do trials. For suggested trial in the responses suggestions. Why multiple? Because each time you call Vizier, it suggests potentially multiple trials. So we have this loop. And we add the measurements. But what measurement? Aha. Create metric, as you see here. Create metric is when we're creating a metric to be sent back to Vizier. It looks simple. It looks like nothing, but that's where the heavy duty happens. The machine learning, which costs you money and time, right here. That is an XGD classifier, which I'm running locally in the memory space. I'm not calling the Google API. I could do that. In fact, the other example, which we won't have time for, shows how to call the Google API. I could call it an Amazon API. I could do anything. Oops, I shouldn't say that, but anyway. And here we're predicting. That's in order to calculate the metric. What is the balanced accuracy of that trial? At the end, I list the optimal trials. And That means I'm asking Vizier to give me the best ones. Why trials in the plural? Because of the Pareto frontier. Because if we have multiple metrics, then it might give me more than one. In this case, there was only one metric, so it will be giving me one. So that was walking through that code. I do want to show you two more things which you can run through yourself. This is using the Discovery API. So you might not be using it because it's working with an older platform. I do illustrate some things here that just I didn't illustrate in the other one, such as the parent category. But here you see Discovery build from document. And it actually builds the API from a JSON document, which is in a bucket. Hard to believe that, not from Python with a bunch of functions that are defined. This one shows you the concept of parent categorical values. It shows you the concept of a log scale where something varies, as you see here, from 10 to the minus fourth to 10 to the second power. And it uses a Google API as opposed to doing it in the container, but Vizier doesn't care. This last one is a notebook that you can try yourself. I'll show you a link in a minute where you can find everything, but I did not make this. The one thing I did was I deleted one bug that was crashing, and I made a few changes so you just run it start to finish without doing anything, without editing the notebook at all. In fact, if you're lazy, you can just look at the fact that I ran it. There's some output here. Here's some output. If you don't feel like running it yourself, but I'm presenting this to you as a lab. So you may want to know where to get all this good stuff. I suggest you just go to bit.ly/Vizier presentation, and that's it. You can remember that, or you can quickly take a photo here. And the organizers will also share this, of course. From the presentation, which you see here, you can get to my GitHub. You can get to that Major League Baseball example. And now I would like to hand it over to you for questions.
Okay, so thank you so much for the presentation, Joshua. Let me quickly see if there's any questions in the chat. So if anyone is interested or to learn more about Vizier or how to apply it, or if you have any other questions around, well, I guess machine learning and AI that Joshua can answer, feel free to ask us in YouTube chat. We can answer it. But yeah, I have a question in general. So if you're a person who's maybe not coming from a machine learning or AI background, so you're someone who has absolutely no idea about how it works, would this, or is there enough resources out there for us to try and use Vizier for something, or is it something that kind of comes later after you've accumulated some knowledge or gone through some other samples?
The first one, this is machine learning operations, MLOps. It's not machine learning. It's not a machine learning.
Yep.
It has a machine learning inside, which is the Bayesian thing, and it is often, although not always, used for machine learning. But really, it's like CI/CD, DevOps, and it's a different specialization. I'm not a machine learning expert, so most machine learning experts don't know a lot about machine learning operations as it happens. So yeah, it's a quite separate thing. You need to know enough to understand that there's a metric you're trying to optimize, that when it says linear, it doesn't mean a linear function, it means a fancy algorithm that uses linear regression. But yeah, you don't need to know the internals of machine learning at all.
Okay, sounds good. Is there anything else that you would give as advice when someone is trying to use it? Obviously, other than what you've done or shown in the presentation, and any like really big pitfalls that you've seen initially?
Yeah, you have to remember that Vizier itself is inexpensive, but you're running expensive processes. So your study really has to succeed. What I mean by that is that a trial may not succeed. It may get bad metrics, and then you say, "Oh no, I have to spend more money." But you do have to design your study carefully, because if a study which is composed of 20 or whatever number of trials is all messed up and you have to do that again, that will cost you money, not for the Vizier, but for the trials.
Yep.
And one thing you can do, and which I suggest you do, which you would do with any sort of development, is run it with very simple examples. That's why they give x squared. It's why they give r sine theta or cosine theta. It's why I did only 2 iterations, which obviously isn't enough. You can change that if you want in the notebook. It's why you can do machine learning on very small data sets that aren't actually going to give a very good answer, but then you do Vizier with all that, and then when you're confident in that, you can move to a fuller data set and a full problem.
Okay, no, this sounds great. And because it's CI and CD, as you said, so like more in terms, well, you compare it to that, so more in terms of operations for ML and AI. So does this, are you able to use this and plug it into any kind of already existing framework for those things, or is it just something that's like very Google specific?
That's what's so beautiful about it. It doesn't plug into any framework at all. As you saw, I called a certain machine learning API inside the container in the memory space. In the other notebook, we call the Google API as a external. We actually do that by invoking command line with command line parameters from Python. It's a bit strange, but whatever. But the whole point is that there is no integration. You do the integration. Now, some people say they don't want to do that. So you can use AutoML or Hyperparameter Tuner, which use Vizier internally. But the thing is that machine learning is so difficult, it's expensive, and you got to get it right, that you can't always just throw the responsibility onto AutoML, because you can produce far better results. AutoML isn't magic either. All it does is call Vizier. So yeah, the beauty is that it's completely disconnected. The only point of connection is the fact that you stream in the parameters and metrics and get back suggested parameters.
Okay, no, that sounds great. Thank you so much for clarifying. There don't seem to be any questions in chat. So again, feel free to share your presentations with us and all the links, so we can share it as well with anyone who's watching or who might be watching later when we publish this video on YouTube. Quick reminder, because we are streaming, this video is going to be published automatically after the presentations. So you'll be able to come back and watch it and revise everything that we've discussed here. But yeah, if that's all the everything to wrap up your talk, Joshua, I suggest we move on to the next talk. So
thank you.
Yeah. Thank you so much, and yeah, have an awesome rest of your day. If you're going to stick around, feel free to do so. If not, yeah, you're probably busy as well. Awesome. Okay, so Kshitiz, do you want to go with your presentation now? Just feel free to share, and we should be good to go.
Yeah, sure. Thanks, Philip. Let me share my screen. So yeah, I hope you can see my screen now.
Yes, I can, and I think everything is good on YouTube as well.
Great, great. So let's talk about generative AI in 2023. So in this presentation, I'd like to go over diffusion models, particularly in this generative AI space. So let me begin by introducing myself. I am Kshitiz Rimal. I am originally from Nepal, but now I live in Krakow, Poland. I'm a Google developer expert on machine learning. I'm also senior data scientist at Brainly, and I hope, like all of you, I'm also a new explorer in this area of generative deep learning. And here is my LinkedIn ID if you like to catch up with me later on. So yeah, so let me go over what we will cover in this presentation. So basically, I will talk about image generation in particular, how it is different from the past and how is it now in the present, and what are the benefits, not only from the deep learning part, but also for community developers and any enthusiast or aspiring artist, perhaps, how they can use these tools. And as a final thought, I'm also going to share some of my own opinion on these things and something that I think is concerning. So yeah, in a nutshell, that's the overall talk about. And like I said, this is not about ChatGPT, unfortunately. I would like to go over that on some other talk, but this talk is mostly about image generation part. And one thing that I like to highlight here is that now deep learning, generative deep learning space is not so different when it comes to different modalities like text or images. You will see later in this presentation that how text play a particularly important role in image generation aspect as well. So these are not really black and white now, because with generative space now all these modalities are interlinked somehow, and this is very exciting also. So let's go over that. So before talking about future or present, let's say let's remind our past. So, and this is not so distant past as well, like it's like 3 or 4 years ago how we used to generate images. So earlier in this space, in generative deep learning space, there are like particularly two different models that was like really powerful and important and plays a crucial role, let's say, like in terms of image generation. So one is VAE, variational autoencoder, or autoencoder in general, and another is GAN, which you might have heard a lot of times in past. So let us talk about what is like what are these and what are the differences between these and the present ones. So autoencoders, basically what they do is that they try to encode the noise that you give as input to your deep learning model, and it tries to encode that into a Latin space, that is Z here, and from that Latin space it tries to generate the image. So they have like this kind of encoder decoder mechanism where they want to first encode the input and then decode from this latent representation of deep learning model. Similarly to that, GANs also do that, but they gamify this approach. So there are like basically two different models. One tries to generate, like fake images or fake artifacts, and the other tries to classify whether or not this is fake or real. So there is like a zero-sum game between these two models, and ultimately we want our generators to defeat these discriminators and also create this realistic artifacts at the end. So these are like really popular in the past, but now suddenly there's this explosion in generative AI, generative deep learning comes from two different models, I would say. First is this diffusion, which is for the images, and another is this development in text area. This is transformer architecture, which I have not included here, but it plays a very crucial role. So before diving deep into what are the diffusion models and how the texts are connected to it, let me go through what were the challenges in the past. So whenever we talk about image generation, these are this trilemma, let's say, on generative model part. So the trilemma is something like either the model can, generate fast sampling or high quality sample, or like they have a diversity in their predictions. So these are like three different areas where we want our generative model to cover. And particularly in the past, let's talk about VAEs, so autoencoders. So autoencoders were fast samplers, like they generate images really fast, and they have also diversity coverage in terms of their predictions, but the quality of their output is not so great. And in regard to GANs, they are fast sampling, they are high quality output, but sometimes there is this problem with GANs of mode collapse, and there are some issues with not so diverse output from the model, and sometimes it's also unstable to train this GANs model. And then we have this diffusion models, and this diffusion models basically are high quality in terms of their output, and they also cover more like different coverage diversity there, but they are very expensive in terms of generating the output. So let me talk about why they are expensive. So when I'm talking about diffusion here, I'm talking about the earlier version of diffusion and not the present one. So in this case, what is happening in the diffusion models is basically, apart from like difference from the VAEs and GANs, is that in original kind of diffusion models, what they do is that they first try to add noise, Gaussian noise, on top of images, and they do so in a stepwise manner. Let's say like 50 steps, 100 steps, 1,000 steps, and And the task for the deep learning model here would be to understand or like recognize noise instead of image, the original image, and so that when they want to generate the image, what they do is that they first try to recognize the noise in the given input, remove it, and after removing the noise from the input, they try to like generate the original artifact, the original image. So basically, in the forward pass and diffusion models, they try to add noise in the sequential manner, and doing so, the hope here is to so that the deep learning model understands how the noise are being added so that they can reverse the whole process when any new noise is given, they can generate the image out of it. So while doing so, as you can see, there are like multiple steps and multiple images are involved and multiple noise addition and so on. So this is very expensive process when it comes to generating images out of noise compared to VAEs and GANs. So that is why it was effective, but it was very expensive in terms of generation. So I'm also assuming here is that all of you are beginners in this area of generative AI. That's why I'm not going into too much detail. The idea here in this presentation particularly is that I give you this overall look about how this space is expanding or developing and how you can play a role here, how you can explore this space, and how you can contribute eventually to make better models in the future. So the talk will be mostly in a high level with developers' point of view, so to speak, than the AI scientist or researcher point of view. So the things here that I will discuss here are mostly applied in nature. So if you want to learn even details about this diffusion models, here are the links. You can go directly there and learn about it. And but basically, in a nutshell, this is what is happening. First, in the forward pass, the model tries to add some noise, and while doing so, it tries to recognize how the noise are being added, and so that it can reverse the process later on when we want to generate new artifacts. So these are the diffusion models, let's say high-level technique on image generation. So as this process is very expensive, so basically, there are like solutions now available in the market today, and these solutions, as I'm showing you right now, they come from different companies, and as you can see and I'm sure you have heard about these names again and again in the news and so on. So basically, these are the four big players, I would say, in terms of generative space, in generative AI space, basically. And we have this Google model called ImageGen, we have this OpenAI model called DALL-E 2, and Midjourney AI, and Stability AI, Stable Diffusions. And they all try to the focus here is to generate the realistic image as possible with text as an input, with let's say more optimized output, let's say. And unfortunately, not all of them are available as open source. So out of here, Stable Diffusion by Stability AI is open source, so we can talk in more detail about it, and we can also contribute as a community. So Midjourney AI, OpenAI, DALL-E 2, they are all like closed source. There is a paper, however, about ImageGen. I am not sure about the open source implementation of ImageGen. Maybe there is, but like in terms of availability, Stable Diffusion is most available model out there in terms of generative AI images, basically. So Stable Diffusion tries to tackle this issue of expensive image generation by going back a little bit to this era of VAEs and GANs, let's say. And here what it does is that Stable Diffusion basically instead of directly adding noise to these images and tries to learn the noise from the images directly, it first tries to encode these images into a latent space using this encoder and decoder mechanism that I mentioned earlier about VAEs. So basically, instead of directly working with images, they try to work with this latent representation from this autoencoder part. And they do the same thing as a earlier diffusion, but on a latent space rather than the original original image. And the benefit of using latent space here is that they are much less in dimension, so it's comparatively less expensive than working on directly on images, and plus we have better output here. So this is the high level diagram of stable diffusion. As you can see, it also takes into account the text part, that you want to direct the model what you want to generate from the text. So basically, I also mentioned earlier that we will be touching on this text part. So with this development in transformer architecture, we have suddenly now this pool of pre-trained text large language models that we can use to encode our text. And basically in this part, in stable diffusion, it uses a model called clip that tries to encode the given text, like let's say a dog looking like a knight in shiny armor, and it tries to encode that text into this latent representation, creates this token embeddings, then it gives that input to this image information creator part, and then it tries to encode that into the latent space, and from there it follows this diffusion steps of adding and removing noise, and then decodes the final image as a generated image here. So all this is happening inside this architecture in a stable diffusion. So basically the same diffusion architecture is happening here, but it also takes into account the text part. It tries to encode it using the transformer architecture, and then it also encodes the image into this latent representation. And the output here, we can see this realistically looking dog, which we exactly want in our case, like this, let's say. And this is, by the way, output from stable diffusion 2.1, which is much better than the older version or recent version 1.5 or something. So as you can see, it's more detailed and high quality. And here in this image is from this blog, which I have included the link. I can share the whole presentation with you later on. So yeah, feel free to go over that as well. So basically, with this availability of pre-trained model and this explosion in generative AI space, few components and areas are emerging from it, and they generally dictate how we move forward with this approach. So these three things that I like to cover in terms of stable diffusion and generative image in particular is text prompt, which is interesting because we are talking about images, but suddenly the text part is also equally important now, not just the image part. So this is very interesting here. So there is this area called prompt engineering, which deals with basically how you design better prompt or the input that you want to give to this stable diffusion models, and then the output that you want. And then there is this area of fine-tuning your model so that you get exactly what you want with your own images perhaps, or your own concept and so on. And also there is this area how we can control the generation part itself, how we exactly get the output that we want, like in a subject level, inside the image, like a day, night, sit down of a person or so on. So how we can control that. So these are the three interesting areas that are emerging now from this diffusion model and this image generation part. And there could be more. I might not have included everything here, so feel free to explore this space. And like I said, I'm also a new explorer in this area, so I'm not an expert in generative AI at all. As this field itself is expanding, this is exciting, and it's very, let's say, enlightening for all of us to learn about new things every day. So feel free to explore here. So let me first go through this prompt engineering. So basically, the idea here is to how you can effectively design your text input, your prompts, so that you get the generated artifact as you like. And these are not limited to images. These can be related to ChatGPT or other, large language models or anything. So whenever you are giving input to your generative AI, not just images, as a text part in a text form, this is very crucial area. So there is this new discipline being developed, and here is this GitHub page that I have included the link, so you can just go there and learn about it. What is the best practices, let's say, about engineering a prompt and so on. So this is really exciting. And another is how we can teach new concept to this stable diffusion models. So we know for the fact right now that these models, if given proper input, they can generate high quality artifacts, and artifacts that are blowing our mind and like near perfect to a like a decade old artist or a more experienced person and so on, or even better sometimes. But how do we teach these large models on new concept? Like there could be some areas where we something that is very custom to us, and we want to teach these models this new concept. So basically, there are few ways you can teach your stable diffusion models or diffusion models about new steps. And I like to, I have included here 4 different ways, and there could be more. And like I said, this field itself is expanding, so it's very hard to keep up as well. So, but these are the 4 areas that I'm mostly familiar with. And out of all these 4 areas, Dream Booth, the first one here, is the most popular and mostly favored by larger community, and they give predictable output than the other 3. And perhaps like there are also new developments in these other 3 areas, so now it could even be different. But besides that, Dream Booth is also like a really important and effective one here, let's say. And so let's talk about Dream Booth in particular, how it is used, this technique of Dream Booth, to teach a new concept to this stable diffusion models. So basically, as we know, we give text as an input to our diffusion models, and we want our output to generate exactly like the text prompt that we have given them. And so in order to teach a new concept, what we can do, and this is the good part, like interesting part about Dream Booth, is that you don't need large examples to teach new concept to your diffusion models. You only need few examples, like 5 6. In the original paper it says something between 3 to 5. So you have 5 different prompts, you have 5 different images associated with that different prompts, and you just give that input to fine tune or to teach new concept to your diffusion models. And the way you do that is by including something called this tag called SKS here that I have included. So basically, let's say you want to teach your stable diffusion concept of a dog. Let's say your model doesn't know anything about dogs. So what you do is that you collect 5 different images of a dog, and you create prompts, something like this is image SKS and dog. This, what it means is that it will highlight that this is the new concept, and this is about this concept called dog. And you just pass that model to your diffusion model, you train on it, and basically what we do is that we calculate loss on what is predicted by the diffusion model and what is expected by us using our data set. And using that loss, we tweak our model iteratively, and so that ultimately the model learns this new concept of a dog. And then you can use this model to generate how many images you want of a dog. So there could be dogs sitting, playing, and so on. So this process altogether takes minutes to train, or in worst case hour maybe, but nothing more than that. So this is very time effective, less data consuming, and so on. So let me give you some of the examples on Dream Booth. So this is from the original paper, and as you can see, the authors try to teach this model about the concept about sunglasses. So they gave these images as an input to train this stable diffusion model, and now after the training they can do something interesting like this. So a sunglass with Eiffel Tower in the background, and you can see the model already knows about Eiffel Tower. Now they know about sunglass. Now they can generate images like this. And there is also this another example about bags. So you have few images of your bag with your prompt, and suddenly now you can go and generate images of diversity about this bag. let's say. And this is really interesting, and it is not only let's say limited to object, but maybe an action on an object, maybe, or the background, and so on. So you can train new concept to your diffusion model however you like. And this is one of the most popular technique right now in stable diffusion part, to train new concept. The other concepts here, they are also equally important, and like they are also somehow popular, and a lot of people use it as well. They also give similar result as the dream booth, but for the convenience, for the time limitation and so on, I have only covered dream booth here. So, and interestingly, as a developer, there are like tons of resources right now you can explore on how you can quickly train your diffusion models on this new concept using dream technique. So there is one guide on Keras example. I hope everyone knows about Keras. This is the framework that we use to train deep learning models. So if you go to keras.io and follow this guide on like how you can train a new concept to diffusion models, there is a detailed guide there as well. And also Hugging Face, the company who is like doing amazing work right now in terms of democratizing this large language models, diffusion models, and so on to the community. They are hosting this event called Dream Booth event, and where they have collaborated with Keras. And so basically, if you are an explorer in this area, you can also take part in this event, submit your own concept and your model, and host it on Hugging Face and be a part of it. So this event is going on right now. So if you want to explore this area, I highly recommend you to go and check it out. Also, like apart from teaching new concept to these diffusion models, there is also this aspect of controlling the output, the desired output out of this model. So one area is, of course, this prompt engineering. Another is this concept being trained. Also, there is this area called control net. This is a new technique that is developed. So using this technique, not only you can teach, let's say, not only like it is not limited to concept itself. Like here, as you can see in this example, what is happening here is this control net is basically a small neural network that you work together with your larger diffusion models. And what basically it does is that you give a bunch of input. Let's say like I want to generate an image of a Tintin on a board, and I want the Tintin image to be of a style of this image, let's say. And I want Tintin, the character in particular, wants to do something like this salsa kind of position. And you just pass this as an input, and with control net, you can generate the output as you like. So here, as you can see, the image of a Tintin generated by this stable diffusion model, with Tintin doing exactly like portrait in this image. So in this way, you can also control the output out of this stable diffusion models. And this is a really popular area right now in control or desired output being worked on right now in this stable diffusion area. And let me share, this is, by the way, something that I did myself. So while exploring control net, I tried to play around, and this was the output that I was able to generate. However, if you go to the official page of control net on GitHub, you will see something this even better output. So with control net, what you can do is in this part, this external network, this external network can be of anything. So this external network can be something that can recognize image segmentation, or edge detection of an image, or pose detection, like in this case, or depth estimation. So in this example here, it is you can swap the models however you like. So there is this small model that you can choose whichever you like. You pass your bunch of input, and voila, there is this output like you desired. So here the authors are using this depth estimation to control the output of a character, and this is the position they want for their character, and they estimated depth out of it. And suddenly, with this prompt for the Stormtroopers lecture, they can generate something like this. So this is really interesting in terms of control desired output here. So I have included the GitHub link about this control net. Feel free to go there if you like to explore. And so fun thing about this, and I would say the most impactful thing about this, even compared to the earlier iterations on deep learning development and so on, is that now suddenly this generative AI part is accessible to all developers, not just the developers on machine learning or deep learning area, but even for someone who has only basic understanding of machine learning, but they are developers on a different space, and they want to explore. Now they can do that, and they don't need to, let's say, be in depth or technically sound to be a part of this development. So what I mean by that is that there are like bunch of tools available right now that you can easily take out of this open source area, use it as you like, fine tune it, tweak it as you like, and get the output you want. And this was not possible before, when there was this VAE and GANs. You needed large data, you needed technical understanding of training, how to do this, and so on. But with this, it's like few things you only need to remember, and suddenly you get the output as you like. So one of this area is this Hugging Face. Of course, they have this library called diffusers. You can just go there, use dataset, models, spaces, play around, check which one is better for you, and pick and use it. So it's very straightforward with this. Another is Keras. Of course, if you are already a machine learning developer or you have used TensorFlow or Keras, they have tons of resources to teach you about how you can use Keras, and particularly Keras CV on generative deep learning part. So all this concept called Dream Booth, they are already covered here in this guide as well. And also there is this GitHub page called Stable Diffusion Web UI. So basically, if you are not a, let's say, machine learning developer or deep learning developer, and you just want to play around with generative AI, now you can do that. And you just need to use this open source GitHub repo, put it on your local machine. There is certainly this web UI for you to explore everything visually. You just download the models from the internet, pick and choose whichever model you want to play with, put your image, put your prompt, play around with your prompt, and you can have the output as you like. And all the techniques that I mentioned, Dream Booth, ControlNet, everything, they are all available as a part of GUI now. So you don't need to write Python code, no tons of technical stuff. You just play around with the parameters here with this web UI. So this is really democratizing this generative image space right now. So this is really powerful. So as long as you are a developer, or you have fairly good understanding of how code works, and you can play around with GitHub repo and so on, you can do that now. So this is really powerful now. And also there is this website called Civit AI. So imagine you trained your stable diffusion model with new concept, new technique, and so on, and you can post your model there. And so you can see hundreds of models there trained by someone else on the internet, and you can just download them on a different concept or so on, whichever you like. And you can also play on top of it, so you can all these things suddenly becomes composable, and you are working on the knowledge added by someone else. And this is really powerful for your like image generation part. So I would highly suggest you to go through this and explore as well. And also bonus links. So the images that I used here, like the image you saw on my first couple of slides, they are all from this website. And apparently they like curated a list of good prompts that can generate high quality images. So you can go and check out the arts they have generated. They are all amazing. So this is kind of bonus link for you all. And yeah, so this is the state, let's say, present in terms of stable diffusion image generation part. So as a final thoughts on future of let's say AI generated art, what I see right now, and these are all my personal opinions, and they are also, I would say, very limited to whatever exposure I have until now. So these are all changing, so don't quote me on this. So the limitation here, as I can see, are these models are really promising, of course, but they are also limited. So if I go back a little bit here on this image that I generated about Tintin on a board, I could generate this image not on a first run, but after like a couple of iterations. So it's not as desired still as we want, So there needs to be some tweaking involved. So it is not as magical as it sounds as well. Like it's very limited, so you have to pick and choose different pose models maybe, or the different prompt, or different art style images maybe. And suddenly after playing around a bit, you will see this like good quality output from these models, but still they are limited. So they are improving, but they are still limited. And of course, like out of all this fine tuning and teaching new concept, they are also expanding, but still they are limited, and sometimes it requires larger GPU, bigger machines, and so on. So only there are few techniques right now that you can use to fine tune your models on local machine, and they also require like 8 GB of RAM at least, or so on. So it's still expensive, and it's still slower in terms of like as we want, as a final thing. So, and they are not equally great for all content types. So for text and images, you can see this abundant and high quality stuff, but it's not as great in video, let's say, or audios. They are improving, but still long way to go, I would say. And with all this, there are also like promises. So of course, like what one thing that we can bet on this generative AI is that it is rapidly developing field, and you will see next year something like totally different, totally new, totally in a whole new level that you see today. And this is like a greater promise. You see, like every day there is this new development being going on, and they are overcoming the current challenges. And even on video spaces, you will see a solution, something called a runaway ML. They are doing their Gen 1 model. They can generate this animated videos from the footage. So it's really promising. And yeah, sooner or later, I think all these limitations will be addressed one way or another. But all this means is that there needs to be a fundamental shift in concept of learning creativity itself for younger generation, because I don't think 10 years from now younger generation will explore art and images or artistic point in that sense same way that we have explored so far. And they might totally use this AI tools as a part of their learning, and they might not focus on improving their craft or by hand or something, but rather how they can improve the collaboration between these different AI tools perhaps. So this is like fundamentally different from what we have done so far. Also, the future means like what is being what does it mean to be an artist now? Because like let's say in 20 years, 30 years, if you consider yourself an artist and there is this human level model for all the art and craft and so on, what will define yourself? What will define what will be the definition for you to be an artist? So maybe the creativity, maybe the idea, who knows? So these are the things that we are tackling right now. And yeah, and the future is that anyone with creative thought, idea perhaps, can create high quality output. So maybe the competition here, let's say for lack of better word, is not just on the final output, but rather what is the idea being explored or put together in that artifact, because everything will look amazing with these tools. So yeah. And the good part here is that this tool, they allow equal opportunity for anyone to explore artistic endeavors. So this is really amazing. Of course, there are like bad sides also, like if they are being implemented in a rapid way, the current jobs and the livelihood of current artists and so on, their workflow, it might impact completely, and there would be suffering, let's say, because disruption comes with price. So yeah, so these are all like good and bad part of these things. So yeah, and thank you so much. This is my small presentation on exploring images. And if you have any questions, I'm happy to answer.
Okay, thank you so much for your talk. It was amazing. Actually, very, very interesting, and something that's constantly being shown around, especially with ChatGPT. You can't open LinkedIn without there being at least 10 posts about it. So you didn't cover that. You kind of went into this more, let's say, creative, artistic expression, which is pretty cool. So maybe in the future we can also organize a talk about ChatGPT. So see what
Yeah,
it's like.
sure.
So yeah, there are some questions from us organizers as well, but if anyone else has any other questions, feel free to share. So Luca is asking if you know about a way to easily integrate any of these tools, any of these APIs within, let's say, regular type of applications, so like web applications or mobile or something like that.
So the one thing that is a tool that is being developed from Google side, it's MediaPipe. So they are working on something for generative space as well. I don't think it's public yet, but MediaPipe being friendly towards on-device machine learning, Android, and so on. This area will be explored there, and also like with Kira's CV and so on, you can generate these models and somehow incorporate that in your mobile applications. So there are ways. It might not be as you like because this is still early on, and these models are really large and expensive in terms of computing the output. Even from my computer, if I want to generate one decent image, it takes more than a minute, let's say, and this is something M1 I'm working on. So as you can imagine, for mobile devices, it will be more expensive, but yeah, something will be covered, I guess. Like if not offline on device, maybe remote with some API, but there will be.
Okay, no, that sounds great. And you mentioned videos. I was really curious. That was one of the things that I wanted to ask as soon as you start talking about these models. So, what do you, or like, is it public, the content that's being done with videos and stuff like that? Is it something that can be easily found online or something? And how do you, or what do you think would be the result in, let's say, maybe this year or like in the next 5 years or something like that? Because obviously everyone is generating images.
I can predict 5 years. So this is impossible. I can't even predict from this year because this is like rapidly changing, you know. But there are like decent models, pre-trained models, open source and otherwise, equally available right now on video. So there is this. If you go to Hugging Face, you will see something like Pix2Pix video, and they have explored something like how you can transfer the styles of one video, and let's say a text from, let's say you have an image, you have a video of a ocean or sea, and you provide a prompt like, I want to convert this into molten lava or something, and they do that right now. It's not as you like, and it might not cover all the videos that you like with different camera angles and so on, but it's going there. And there is this company called Runway ML, if you have heard about it. So they have this Gen 1 model being advertised. I don't know for sure because I don't have access of it right now, but looking at the prompts and looking at the recently published animated movie they created entirely out of this studio. So these are really promising, I would say. Like if not now, maybe in 1 year, things would be completely different in terms of video, video generation.
Okay, that sounds great. And maybe like a philosophical question to some degree, but do you see any like very impactful ways of using these models? So, for example, people can generate art nowadays, and they can obviously use some ways to maybe monetize themselves or create some content that's being monetized. But do you see something more in the space of trying to improve like the public systems or something like that? Or for example, how machine learning is being used in medicine. Are there any available use cases right now or something that you've heard of that where generative models are being used?
Yeah, I mean, AlphaFold and so on, they are using it for protein structure, like prediction and so on. So generative models, they are not limited to videos, images, and so on. So for a model, deep learning model, it's like general tensors or vectors, let's say. And it's up to you to how you want to provide input to the model, right? It all depends on how quality output or the desirable output it can provide. But anything that involves creation or predictions, I mean, I would say sky is the limit here. Like medicine, drug discovery, and so on, you can generate new molecular formulas. Who knows? I mean, this is like really exciting stuff. All we see on images, they are like a publicly less accessible part where we recognize suddenly, and now they are popular. But there are like, there could be new industries, let's say, coming up in future, which can explore these areas, on totally different things that we imagine right now.
Okay, no, that sounds great. I don't think there are. Let me just quickly scroll. I don't think there are any other questions right now in chat. But if there is anything else similar to Joshua's presentation, we'll share around, or it will be available on YouTube, so we can definitely share. And if you have the time to get involved or something like that, you can always drop some answers. On top of that, we'll share your presentations and this content. So yeah, again, thank you so much for participating, and I don't know if you have any final words before we go.
Well, not as a final word, but like, this is an exciting area to explore right now. And like I said, I'm also a new explorer in this area because this thing is still new. So yeah, let's explore together, I would say. Like, if you have new ideas, let's collaborate. Like, this is exciting stuff, and any way we can contribute to the community. So yeah.
Awesome. Yeah, no, that sounds great. Especially like whenever there's something emerging, the more, and if it's open source to some degree, the more people that participate, the better the output is going to be, I guess. And also, you can find really good, fun use cases when you're working with other people. So yeah, that's an awesome message. Okay, so thank you everyone for joining us. Thank you for being here. Essentially, this is it from us. Until next time. So we'll publish all of this content on YouTube, as well as some other places, such as our Discord and our other social media. So if by any chance you sorry, excuse me. So if by any chance you've missed any of this, or you want to dive deeper, or you want to get in touch with our presenters, feel free to let us know, to follow us around, and yeah, we'll see you in the next event.